Can a plant actually have more protein than ground beef? I'll show you exactly which one, and the number will shock you. Everyone thinks beef is the king of protein. However, one common seed plant delivers 31 grams per 100 grams.
Someone is standing in a supermarket right now. Freezer aisle. Fluorescent lights humming above rows of packaged meat. A hand reaches out, picks up a package of ground beef, turns it over, reads the price, then sets it back down. Watch that moment carefully, because it is not just a shopping decision. It is a calculation. It is a person doing quiet math in their head, weighing what their body needs against what their wallet allows. And that calculation is happening in supermarkets across every city, every week, without pause. Protein has become expensive. Not inconvenient. Expensive. But 3 streets from that same supermarket, on the second floor of an ordinary building, someone is producing more protein per square foot than that entire meat counter combined. No farm. No soil. No supply chain. No refrigeration. No animals. No waiting for anything to grow for months. Just a windowsill. A shallow container. And 7 minutes a day. The plant responsible does not look like a revolution. It looks like a simple vine. But its seeds, when measured in a laboratory, carry protein levels that sit between 29 and 42% by dry weight. Beef, by the same dry weight measurement, lands around 26. A plant seed quietly outperforming animal muscle. That fact exists. It has been published. It has been measured. And somehow most of the world never heard about it. That is not an accident. This plant has 4 wings running along its pods. Actual geometric wings, longitudinal ridges that run the full length of the bean from tip to stem. Botanists saw those 4 wings and named the plant after them. Sophocarpus tetragonalibus, the winged bean. In Papua New Guinea, it has been growing for more than 2,000 years. 2,000 years of cultivation, of seed saving, of cooking and eating and surviving on this plant, while the Western world spent decades looking somewhere else entirely. Hi viewers, here is a simple question. When prices go up at the grocery store, what is the first thing you cut from your shopping basket? Leave the answer in the comments below. Just one word is enough. The National Academy of Sciences assembled a panel of agricultural scientists in Washington in 1975. Their task was to find overlooked crops with extraordinary potential. They reviewed hundreds of candidates, and when they published their findings in 1981, they used a phrase that is almost unheard of in scientific writing. They called this plant a supermarket on a stalk. That phrase was not poetic exaggeration. Every single part of this vine is edible. The young pods taste similar to green beans. The mature seeds rival soybeans in protein. The leaves compare nutritionally to spinach. The flowers can be eaten. And then there is the part underground, the tuber, the hidden structure beneath the soil that almost no one in the West has ever seen on a dinner plate. That tuber can reach 20% protein. A common potato sits at around 5. The same harvest weight. 4 times the protein. This plant was studied by NASA for long-duration space missions. Because what this plant does when it germinates, the chemistry that unfolds in the first 5 days of growth, changes everything about what it means to produce food at home. The seed that sits dormant in a jar today is not the same object it becomes on day 5. Something wakes up inside it. And what wakes up is more nutritious, more digestible, and more available to the human body than anything the dry seed contained before. That transformation is the real story. And it starts with 7 minutes. 4 wings. That is where the story begins, physically. Run a finger along one of the pods and 4 raised ridges meet the skin, running from one end to the other like the edges of a compass. No other common bean grows this way. No other legume in a typical market carries that shape. The geometry alone should have made it famous. Instead, it made it foreign. The winged bean belongs to the same family as soybeans, lentils, and chickpeas. But it does not behave like any of them. Most legumes ask a farmer to choose. Grow it for seeds, or grow it for leaves, or grow it for pods. The winged bean does not ask that question. Produces everything at once. Young pods harvested early taste clean, slightly sweet, similar to a fresh green bean but with a texture that holds its shape even after cooking. Let those same pods mature and the seeds inside them become dense protein packages that laboratory analysis places between 29 and 42% protein content, depending on variety and growing conditions. That range is not a rounding error. That range sits above beef, above chicken, above most animal proteins that dominate the global food market. Think about that for a moment. A seed, on a vine, outperforming muscle tissue in the one nutritional category that drives billions of dollars in global food sales every single year. The leaves of this plant are edible too. Not as decoration, not as garnish, but as genuine nutrition, comparable by analysis to spinach. The flowers, pale blue and violet, can also be consumed. In parts of Southeast Asia, cooks use them the way others use herbs, folded into dishes as both color and food. There is almost no part of this vine that goes to waste. But the underground section is the one that rewrites every assumption. Beneath the soil, the winged bean produces tubers. Swollen, starchy, underground structures that look at first glance like a modest root vegetable. Except they are not modest. Dry weight protein analysis of the winged bean tuber reaches around 20%.
Is it the same thing to get your protein through some beans versus eating some beef? We hear this a lot of the plant-based community, well, you can just get your protein through beans. And listen, I like beans. I had some carne en su jugo my wife made, and I put some pinto beans on that. It was delicious.
A common potato, the most widely consumed tuber on the planet, averages closer to 5%. The comparison is not even close. For every gram of protein a potato offers, the winged bean tuber quietly delivers 4. That fact was documented, published, circulated in agricultural science reports. And yet the winged bean tuber does not appear in a single mainstream Western grocery store. NASA looked at this plant seriously. When researchers were designing food systems for long-duration space missions, where weight, space, and nutritional density are absolute constraints, the winged bean appeared in the research. A plant that feeds from air, produces from multiple structures, and delivers protein at levels that compete with animal sources, that is not an agricultural curiosity. That is an engineering solution. The United Nations did not use casual language when it described this crop. Calling something the most promising food crop of the 20th century is a statement with weight behind it. Those words came from agencies that measure food security across populations, that track malnutrition at a global scale, that understand what it means when a protein source is accessible, growable, and independent of an industrial chain. They saw the winged bean and recognized something. The plant had been growing in Papua New Guinea for more than 2,000 years before any Western institution noticed it. Farmers there had not been waiting for scientific validation. They had already done the long experiment. 2 millennia of seed saving and cultivation is a data set that no laboratory study can easily replicate. In the Philippines, it carries local names that shift from province to province, each one representing a different history of use, a different way of cooking, a different relationship between a community and its food. In Indonesia, in Thailand, in parts of India, it shows up in local markets under names that Western visitors walk past without recognition. It was always there. The world simply chose not to look. And when the world finally did look, what happened next was not a celebration. It was a decision, a quiet, economic decision made not in a field but in a funding office. And that decision is the reason most people reading this have never tasted a winged bean in their life. Washington, D.C., 1975. A panel of agricultural scientists sat together with a specific assignment. Find the overlooked crops. The ones that local farmers had grown for generations while global agriculture passed them by. The ones with real nutritional value and real potential for feeding people at scale. Review the candidates, rank them, and publish the findings. They reviewed hundreds of plants. They selected the winged bean for special attention. 6 years later, in 1981, the report came out. It was a scientific document. Careful language, measured conclusions, peer-reviewed analysis. But inside that careful language was a phrase that stood apart from everything around it. They called it a supermarket on a stalk. That phrase traveled. Agricultural researchers in Asia began serious development programs. Research stations in Nigeria tested cultivation methods adapted to local soil. India explored it as a candidate for protein supplementation in regions where meat was either too expensive or culturally absent from the diet. For a window of time in the early 1980s, the winged bean looked like it was finally going to arrive. Then something shifted. Funding moved. Programs closed. Research priorities changed direction. And the winged bean, after its brief moment at the center of global agricultural attention, quietly returned to the farms and gardens of Southeast Asia where it had always been growing, and where it had never needed anyone's endorsement to survive. What happened? The answer is not dramatic. It does not involve a single decision or a named individual. It involves a structure. The structure of how industrial agriculture generates revenue, and why certain crops are incompatible with that structure no matter how nutritious they are. The winged bean fixes nitrogen. In practical terms, that means the plant forms a partnership with bacteria in its root system. Those bacteria take nitrogen directly from the air and convert it into a form the plant can use as fertilizer. The winged bean feeds itself. A farmer who grows it does not need to buy synthetic nitrogen fertilizer in the quantities required by most commercial crops. That is money that does not change hands. That is a recurring purchase that never happens. In tropical climates, the plant behaves as a perennial. Comes back year after year from the same root system. A farmer plants it once and harvests from it repeatedly. That is not a model that generates annual seed sales. That is not a crop that drives repeat purchases of inputs. That is food security built into the biology of the plant itself, which is precisely what makes it valuable to a farmer and precisely what makes it invisible to a supply chain. There is no conspiracy here. There does not need to be. When a crop does not generate recurring revenue from seeds, fertilizers, pesticides, and replanting cycles, it does not attract the capital that funds research, development, marketing, and distribution. It is not suppressed. It is simply underfunded year after year until it disappears from institutional memory while continuing to grow in the gardens of people who never stopped planting it. The winged bean did not fail. The system had no mechanism to profit from its success. And while that system looked elsewhere, families in Papua New Guinea and the Philippines and Indonesia kept harvesting pods, cooking tubers, saving seeds, and doing exactly what their grandparents had done, without any report from Washington telling them it was worthwhile. The knowledge survived where it was never at risk. But for the rest of the world, the window of mainstream attention closed. And when it closed, so did the possibility that someone standing in a supermarket freezer aisle might have grown up knowing there was another option entirely. Now that window is open again. Not because an institution reopened it. Because a windowsill and a 7-minute process just made the institution irrelevant. A dry seed is not food yet. Not completely. It is potential. Compressed, dormant, locked behind a chemical armor that the plant built specifically to prevent premature digestion. That armor is not a flaw. It is a survival mechanism. A seed that could be easily broken down would not survive long enough to germinate. So the plant protects its investment with compounds designed to interfere with digestion, to resist breakdown, to outlast the conditions that would destroy it. Then water arrives, and everything changes. Within hours of soaking, the seed begins activating enzyme systems that have been dormant since the pod dried. Starches that were locked in storage structures begin converting into simpler sugars. Proteins begin shifting toward forms the human body can access more directly. The chemical armor starts coming down. One group of compounds called trypsin inhibitors, which interfere specifically with protein digestion, can decrease by 60 to 80% during germination, depending on the timing and method. That number deserves to sit alone for a moment. The very compounds that made the raw seed harder to digest are dismantled by the seed itself as it grows. No heat required. No industrial processing. The biology handles it. Vitamin C tells a different story. Dry winged bean seeds contain very little of it. But as germination progresses across the first 5 days, the seed begins synthesizing vitamin C from precursor compounds already present in its tissue. By day 5, under the right conditions, levels that were near zero have risen sharply. The seed is manufacturing nutrients it did not visibly contain before. Not releasing stored vitamins. Manufacturing them. That distinction matters. because it means the sprout on day 5 is a nutritionally different object than the seed on day 0. Not better stored, genuinely transformed. Protein digestibility follows the same direction. Raw seeds digest at around 65% efficiency. Sprouted seeds, measured after the germination window, reach above 85%. The protein was always there, but after germination, the body can access dramatically more of it. Sprouting does part of the digestive work before the food ever reaches the stomach. Day 4 to day 5 is the critical window. At that point, the cotyledons, the first 2 structures that push outward from the germinating seed, have fully expanded. They still carry the concentrated nutrition of the original grain. The enzymatic improvements are at their peak. But the stem has not yet begun its aggressive push upward, which would divert energy away from those nutrient-dense structures and into elongation. Harvest at day 5 and the texture is clean, slightly crisp with a mild flavor. Wait past day 7 and the flavor sharpens, the texture softens, and some of the nutritional advantage begins redistributing into structures that are less useful for eating. The window is real, and it is short, and knowing exactly when it opens is the difference between a successful batch and a missed opportunity. 7 minutes is enough time to set this process in motion. Not 7 minutes of watching. Not 7 minutes of active work spread across 5 days. 7 minutes on the first day to prepare, and then 2 minutes twice a day to maintain. That is the total time investment for a system that produces measurable protein continuously, without soil, without sunlight, without seasons, and without a supply chain that can fail. The method itself is not complicated. But the details inside it are the difference between a batch that thrives and one that does not. And those details are exactly what comes next. Start with the seeds. In Asian grocery stores across most major cities, the winged bean is sold dry, sometimes labeled as Goa bean, sometimes as angled bean, sometimes under regional names that vary by the country of origin printed on the package. Online seed suppliers carry it. Seed exchange networks carry untreated varieties specifically intended for sprouting. 1 kilogram of dry winged bean seeds costs a fraction of what 1 kilogram of beef protein costs at retail. But that comparison is misleading because a kilogram of seeds is not one meal. It is dozens of harvests. It is weeks of production. It is a protein supply measured not in grams but in months. When the seeds arrive, do one thing before anything else. Spread them out and look at them. Remove any that are cracked, visibly darkened beyond their natural color, or show any signs of surface damage. This step takes 30 seconds. It is not optional. Damaged seeds are the entry point for bacterial growth that can compromise an entire batch within 48 hours. 30 seconds of inspection protects 5 days of work. Now soak them. Place the inspected seeds in a glass jar or a deep bowl. Cover them with room temperature water at a ratio of roughly 3 parts water to 1 part seed by volume. They will absorb water and expand. Seeds that are only partially hydrated germinate unevenly, and uneven germination creates pockets of moisture imbalance that invite mold. Full, even soaking is the foundation of a clean batch. Soak for 12 to 24 hours. Not less, not more. Less time leaves some seeds underactivated. More time tips the water chemistry toward bacterial growth. The
Leave it in
12
the
to
comments.
24-hour window
Sometimes
is not
the most
approximate.
valuable thing is
It
not hidden in a
structural.
laboratory.
After soaking,
It is
drain
beside a
completely.
road,
Rinse
climbing a
with
fence,
fresh room
or in
temperature
someone's
water.
garden
Drain again.
who never uploaded
Then
it to
hold the
the internet.
container at an angle for 30
Now
seconds
try a
and
simple
let every
experiment.
remaining drop fall
Go
out.
into any
Standing
supermarket
water
this week.
at any stage of the
Spend
process
1 minute
is
in
the
the meat
single
section.
most common reason a batch fails. Not temperature. Not seed quality. Standing water. The container matters less than most people think. A commercial sprouting tray works. A colander lined with a thin cloth works. A window box with drainage holes drilled into the base works. What the container must do is one thing only: allow water to drain freely and allow air to circulate around the seeds. No container that traps moisture will produce a reliable batch, regardless of how expensive or purpose-built it looks. Position the
There's
container
a bean
away
that
from
produces
direct
more
sunlight.
protein per
This is
square foot
counterintuitive.
than raising
Most
cattle.
growing things need
It
sun.
needs no land,
Sprouts do
no
not need
fertilizer,
direct sun.
and no
They
sunlight.
need indirect light or even
It grows
gentle
to
shade.
harvest in 5
Direct
days
sunlight
on your
heats the seed
windowsill.
mass, accelerates
NASA
bacterial
studied it
activity,
for space
and can
stations.
produce a bitter
The
edge
United
in the
Nations
flavor
called
that
it the
appears
most
by day
promising
3
food
and does
crop
not
of the
go
20th
away.
century,
A countertop
and then it
away
nearly
from the
vanished
window
from
is
Western
ideal.
awareness.
The inside
A
of a
single
cabinet
box
with
and
the
a
door
window
left
can
slightly
produce
open
fresh
works
protein
equally
all
well.
year long.
Now
And
rinse
by the
twice
end of
a
this
day.
video,
Morning
you will know
and night.
exactly how.
Every time,
Welcome
use
back
room
to Botanical
temperature water.
Vault.
Pour it over the
Before we
seeds.
get into the
Shake the
practical
container
guide,
gently
tell me
so
something.
every seed gets wet.
Have you seen this
Then drain
plant
completely.
growing wild
Each
near where
rinse
you live?
removes the metabolic byproducts
Leave it in the
seeds
comments.
release during germination
Sometimes the
and
most
replenishes
valuable
the
thing is not
oxygen
hidden
the
in a
developing root
laboratory.
tips need.
It is
Missing
beside a
one
road,
rinse will not
climbing
destroy
a fence,
batch.
or in
Missing
someone's
2 in a
garden
row on a
who
warm day
never
very
uploaded
likely
it to
will.
the internet.
Temperature is the
Now
invisible
try a
variable
simple
most
experiment.
people overlook.
Go into any
Between
supermarket
20 and
this
30
week.
degrees Celsius
Spend
is
1
the
minute in
range
the
where
meat
germination
section.
moves cleanly and contamination stays
Watch the
low.
people standing
Below
at the
20,
counter.
the process
You will see
slows.
the same
The
pattern
seeds still
again and
germinate,
again.
but the
They pick up
timeline
packages
stretches.
of ground
An
beef,
animal
look at the
raised
price,
for 18
and
to
put them
24
back
months.
down.
Tons of feed
In many
grain
cities
consumed
across the
over that
United
period.
States, you
Much
see
of
the
it food
same
that
number
humans could have
over
eaten
and
directly.
over again.
Thousands
Dollars
of
per
liters
pound.
of water,
And
land,
it is not just the
veterinary
price.
input,
It is the
transport
expression.
from a farm to
It
a
is the
processing
mental math
facility,
in the aisle.
industrial
Because protein has
refrigeration
become
at every
expensive.
stage of the chain.
But on a windowsill
packaging,
3 blocks from that same
distribution,
supermarket,
retail markup,
someone is producing
and at
protein
the end of all of that,
with no
a package
land,
in a freezer
no
aisle that a
animals,
shopper picks up,
no refrigeration,
reads the price on,
and no
puts
supply
back down.
chain.
One window
Just
box,
a shallow tray
tap water,
and tap water.
7 minutes.
The plant
The contrast
responsible
is
has a
not just
detail that sounds
logistical.
almost
It is
invented.
structural.
Its
Meat
pods
exists
have 4
inside a supply
longitudinal
chain
wings.
that has dozens of
That
points
is why
where it can
botanists
fail.
named it
Fuel shortages
Sulfocarpus
affect transport.
tetragonalobus,
Weather affects
the winged
feed crops.
bean.
Price spikes
In the
at any
Philippines,
point
many
in the
farmers
chain
know
move
it by
directly
local
to the
names that
consumer.
change from
The home
province
sprout
to
system
province.
has one
In
dependency,
Indonesia and
water
across
pressure.
Asia,
And
it
in
appears in
virtually
markets
every
under
urban
other
environment
common
where a
names.
person can watch this
In
video,
Papua New
water
Guinea,
pressure is
where it
the
has been
last thing to
cultivated for
disappear.
more than
This is what
2,000 years,
food sovereignty
it has
actually looks
dozens
like.
of names,
Not stored
and each
cans
one
in a basement.
represents
Not
generations of
expensive
cooking soil,
freeze-dried provisions.
climate, and survival.
Sovereignty is a skill.
The West
It is the
nearly
ability
forgot
to
it,
produce essential
but science
nutrition
did not
inside the
forget it
space available
completely.
to any ordinary person.
In
using
1975,
inputs that cost
the National
almost
Academy
nothing,
of
and
Sciences
knowledge
brought
that belongs
together
to no
a panel of
corporation and cannot
agricultural
be priced out of
scientists
reach.
in
The
Washington,
winged bean
D.C.
waited 2,000 years
Their
for
task
this
was
moment.
straightforward
Not
to
in a
identify
laboratory,
underused tropical
not in a
plants
funding report.
with exceptional
In the
potential.
soil of Papua New Guinea,
They
in the
reviewed
gardens of the
hundreds of
Philippines,
candidates
in the market
and
stalls of
selected the
Indonesia,
winged bean for
in the hands
special
of farmers
attention.
who never needed a
The
scientific
report that
panel
came
to
out
tell
of that
them the
work,
plant was
published
worth
in
growing.
1981,
Seeds do not
used
understand
unusually
markets.
vivid language
They
for a
understand water,
scientific document.
temperature,
They
and
called
time.
it a supermarket
Give them
on a
those
stalk.
3 things and they do
That
not wait
phrase
for
stayed
permission.
for a reason,
They simply
because
grow.
nearly every
And
part
now
of this
one
plant
thing
is
remains.
edible.
There is
The
another
young
plant.
pods taste
It
similar
grows
to green
faster than the
beans.
winged bean.
The mature seeds
fixes
contain
nitrogen
protein
more
levels that
aggressively.
rival soybeans.
It produces in
The
conditions
leaves provide
where almost
nutrition
nothing else
comparable to
survives.
spinach.
And buried
The flowers
inside its
can also be
chemistry is a
eaten.
compound that
And
researchers
what
have
almost
been studying
nobody in the
quietly for
West
nearly 15
sees
years.
the underground
A
tubers,
compound
that
that
hidden
appears
part
in
beneath
published
the soil,
literature in connection
can
with
reach
cellular
20%
repair,
protein.
metabolic function, and
To
longevity
put that in
research.
perspective,
Not fringe
potatoes
research,
are usually around
peer-reviewed,
5%.
institution-funded,
That means
ongoing
that for
research.
the same harvest
That
weight,
plant does not
the
appear
tuber of
in
the
any
winged
Western
bean can
grocery
deliver
store.
4 times
It does
more
not have a
protein
product line.
than a common tuber.
It does not have
but
a
the
marketing
real story
budget.
is in the
It
seed.
has something more durable
Laboratory
than either of those
analyses
things.
published in
It
food
has
science
2,000
journals
years of
have measured the
uninterrupted
protein
human use.
content of the
And that
winged
story
bean
is coming in
between
the next video.
29%
Do not miss
and
it.
42%.